All right, so this is how we do testing mu with sigma unknown. Since we don't know sigma and we're testing our mean, we have to use our t distribution. So we're going to look at the three methods: confidence intervals, classical method, and the p-value. This is, again, the way you're going to do your case study. I'm going to do the number 19 on page 539. So let's first figure out what kind of information we have. We have, or the 2002, the mean age of an inmate on death row was 40.7. According to data obtained from the U.S. Department of Justice, a sociologist wants to test a claim that the mean age of a death row inmate has changed since then. She randomly selects 32 death row inmates and finds their mean age to be 38.9 with a standard deviation of 0.6. Test the sociologist's claim at the level of significance 0.05. Now, this is a simple random sample because she randomly selects, and because n is greater than or equal to 30, it is our sample is normally distributed. We can use our t distribution. So the first way we're going to look at is confidence. Again, just like what we did last chapter, x bar plus or minus p alpha divided by 2 times s over that. P alpha divided by 2 is, of course, t 0.025. Our alpha is 0.05, got to divide it by 2. And degrees of freedom is 1 minus our sample size, so 30. When we do our NT, we get negative 2.04. So x bar is 38.9 plus or minus 2.4 times our sample 9.6 square root of 32. So we get a confidence interval of 35.44 and 42.36, lower and upper bound. If we look at our mean, 40.7 is in the interval. Thus, to reject. Oh, sorry, I forgot to write my hypothesis. H naught, my null, is that mu is, what did I say it was? 40.7. And because we're just looking to see if it's changed, we're doing a two-tailed test. Which one is not equal to 40.7? So we fail to reject. That's the confidence interval way. Not really any different than what we did with the normal distribution. Now, let's look at our method. So we want our diagram here. It's filled. And mu is equal to 40.7 and not equal to alternate hypothesis. We need to find our two values. Well, we've already done that. We did our NT, 0.25. 0.025. We cut it in half. Degrees of freedom, 2.0304. So negative 2.04 and positive 2.04. So we don't want our values to fall in either one of those. Obviously, our test statistic's only going to fall into one of those. So our test statistics are E naught is x bar minus mu over s divided by square root of n, which in this case is 38.9 minus 3.7 divided by 9.6 divided by the square root of 32, negative 1.06. That somewhere in between those critical values, not in the critical region, not in critical region. So fail, reject. Obviously, we wanted the same thing. We don't want to have a different result doing a different test. Last one is our p-value. For the p-value, we want to see the probability that we get the value that we got. So, P, C, D, F. And because, even though we have a two-tailed test, because our t-score, our t-naught, our test statistic is negative, we're going to look at the left side, see the probability that it's less than our test statistic. But because it's tailed, we need to multiply it by 2. So 2 times T CDF, 9 EE 999, to our test statistic, and then our degrees of freedom. So we get a p-value of 2969. Our p-value is not less than our alpha, 0.5. What that means is that we got an almost 30% chance of getting the data that we got if the mean is 40.7, like we said. So we failed to reject. We can't say that it's changed. So, finally, our conclusion. We have insufficient evidence to reject the null. There we go. We cannot support the claim that the mean hetero inmates, definitely misspelled a lot of that, has changed from, we gotta look at the year, 2002 to current year, based on our sample, at a level of significance of 0.05. That's our conclusion. We got failed to reject using the p-value method. Got 0.2969. We got a critical value of negative 1.06, not inside our region, classical method. Our confidence interval was 35.44 to 42.36. Our mean was inside there, so we failed to reject all 3 times, which of course we should. That is our conclusion. And we did check to see if it is normally distributed, a simple random sample, and n big enough.